The Pilatus PC-24 is a luxury 12-person jet that can fly high and fast, but land in rugged places you normally would never see jets. It has some incredible capabilities, and so our demo pilot Gerard is going to walk us through some of its key features.
Charlie, we have our cargo door, which is a main feature of the PC-24. One of the things that you can see on this trailing edge here, it's a straight trailing edge that allows you to drive a forklift up to the cargo door for loading. Most other business jets, the trailing edge is swept back, which would preclude that from occurring. Let's go ahead and go to the cargo door and open it.
This is just pretty cool.
So you can see in the cargo section of the aircraft, it's quite large, a lot of capacity for use to store, load equipment. One of the neat features of the aircraft also is that it's reconfigurable. You can remove seats. It's a pilot procedure to remove those, and you can reconfigure this to load any type of cargo. As we discussed, one of the nice things about the wing is the straight trailing edge. But as you notice here, when we design a cargo door, we have to move the engines away so we can operate the cargo door behind the wing. Normally in most of your business jets, the engines will sit just over the trailing edge of the wing to provide FOD protection for the engines. So the fact that we can land on prepared, unpaved surfaces such as grass and gravel, and particularly gravel, we had to come up with a design to ensure that we were protecting our engines. You can see here when the flaps are fully extended in the 33 position, the flaps act as our mud guards to protect any FOD from going through the engine. We have an operator up in Alaska that regularly lands on gravel for the last few years, and we have never seen any damage to any FOD ingestion related to anything on the runways.
Do the flaps take a beating in the process?
They can, and you can see here there's a protective surface here that also extends on the backside, so they're beefed up in that area to be able to handle that gravel impact on the flap section. One of the things that we discussed earlier, what gives us the short field capability on the airplane, it starts with the approach speed. Mid-90s on most of your approach speeds with the flaps at 33. And you can see that's a pretty large double Fowler flap there to allow us to do that. Then as you can see over here, after the aircraft touches down, the utility management system will state that the airplane's on the ground and will automatically deploy what we call lift dump. The lift dump is all the big spoilers here, but also the outboard spoilers will also be extended. What that does is it puts all the weight onto the main landing gear, and then we use anti-skid to stop the airplane. The anti-skid is a pretty neat system. If you actually landed with your brakes applied, it knows the wheel spin up. It's not going to flat spot your tires. It's a pretty advanced algorithm to allow the airplane to stop in such short distances. One other thing to talk about here is we talk about our low approach speeds. As you know, on low approach speeds, for roll control, you want to have a very large aileron. But a large aileron at 45,000 feet, at Mach 0.73 or 0.74, can limit you. So you want to limit the size of your aileron at altitude. So what the system will do automatically is when the flaps are extended at 8 or more, the roll spoilers will extend to supplement roll control when you're at slow speeds. The pilot and aircraft will now demonstrate this functionality. So the engines on the PC-24 are the Williams FJ44-4A QPM. I'll talk about the QPM section in a second, which is enabled on the right engine. Before we get to that though, one of the things that you can see, the nozzle shape is slightly different. This is called an exact nozzle that was designed for Pilatus by Williams to allow us to vector the thrust up to reduce our takeoff roll.
The exact nozzle incorporates a smoothly curved ramp along its top surface, so that when airflow is at relatively low speed, such as during takeoff, the exhaust stays attached to the curved surface and is deflected upward by approximately 3 degrees, parallel to the angle of the exact nozzle. This small vertical component of the thrust vector acts to push the tail of the PC-24 down, helping rotate the aircraft and reduce takeoff distance. At high speed during cruise flight, the exhaust stream expands and exits away from the engine in a conical pattern, eliminating drag.
Another interesting feature of our FJ44s, which is not on older models of the 4, is the pre-cooler that is inside the engine. Most other aircraft have the pre-cooler in the tail section and or the pylon. You can see the tubes that go around just right by the turbine section. Bypass air off the fan will go through that area and then pre-cool the bleed air before it enters into the bleed air system of the aircraft. The Wright engine has what I mentioned earlier was QPM. QPM stands for quiet power mode. Essentially, it allows that engine to operate as an APU. Both engines are the same, which is really important, so you could switch one from right to left. When the engine is placed in the right engine position, the FADEC enables electronically the QPM portion of it. So you do not have unique engines left or right. Both engines are the same, only enabled on the right engine. So what occurs when you select QPM? When you select QPM, it slows the fan N1, N2 down and also reduces fuel flow, very similar to an APU. The load of the generators are normally 400 amps. It reduces it to 250 amps, again, because the engine is operating at sub-idle speeds, but that is sufficient amperage to either cool the airplane in the hot summer or to heat the cabin when it's in the winter. Another thing about the QPM is that it saves you a lot of money, mostly because you don't have another engine to maintain, and you also don't have the weight of an additional engine being an APU. So the first questions that you should be asking me if you're looking at purchasing an aircraft is, does QPM cost hours on your engine?
For an overhaul.
Overhaul time, and it does not. Williams has the QPM time programmed into the design of the aircraft. You'll use it sometimes more, sometimes you'll use it less, but it doesn't cost any time to your overhaul. So there's no cost in terms of overhaul time to use QPM, which is very important.
Cool, they got the QPM going, quiet power mode. Honestly, it's pretty quiet, and it doesn't have that same like hiss as an APU sometimes has. Sometimes you got the, the whine of a turbine. This just sounds like a real low idle engine, because that's what it is.
So as you know, in multi-engine business jets, a V1 cut or a loss of an engine on takeoff can create a significant amount of yaw on the aircraft. So we have a multitude of safety features that help the pilot through that situation. So if you're on takeoff roll and you lose one engine, the first thing that's going to occur is that the utility management system is going to recognize the reduction of power on the one engine, and it will automatically apply what we call rudder bias. Rudder bias is using the autopilot servos to put in the appropriate rudder into the good engine. So the first thing you have is the rudder is going to deflect for you. You as a pilot still need to be applying pressure in that situation. Once you get the gear up, we select at 50 feet the yaw damp. As soon as the yaw damp comes on, this next safety feature comes in, which is auto yaw trim. What that will do is it will trim off all the pressures based on the yaw damper inputs so that you can just monitor the rudder. So the traditional way where there's a lot of trim changes when you're at slow speed and applying the rudder and then you accelerate and you have to take all that, that's automatically all done for the pilot. Where it's very noticeable is when you're doing a single engine missed approach. Traditionally, when you do a single engine missed approach, you're right at your minimums. We've all been in the simulator and have had to do this in the past. And when you apply that power, there's a big yawing motion, and the pilot has to counter that appropriately so that the airplane can have the proper ground track. Well, in our system here, with auto yaw trim and auto throttles, all I do is hit the takeoff go around button. The throttles will come up automatically with that single engine, and the auto yaw trim will come in to trim the airplane so that you maintain your course.
Cool.
So you hit one button, you can monitor everything, and it's a really neat safety feature on the aircraft. So Charlie, as you notice, we've already discussed how we protect the engines from FOD by using the flaps, but the underside of the aircraft is also important to protect from FOD. You can see that we beef up certain areas such as the antenna for protections, and there's a film that's applied to the bottom of the aircraft to protect the paint in case there's any rocks. We also use this mud guard that's pilot removable. The reason that it's pilot removable, as you know here, and you've seen us move aircraft around, is that with a tow barless tug, you want to grab the wheel. Obviously, if this was on, you couldn't grab the wheel. So this is a pilot removable item. So as you can see here, I'm just going to install this. That's all it takes. A couple pins and you have your mud guard installed.
You know you're about to have fun in your jet when you throw a mud flap on it.
Exactly. One of the things also to note is that there's no performance change or no changes to anything for the pilot if that's installed, so you can operate the airplane as if that was not installed.
There's room for it in the wheel well and everything.
Exactly, yeah, we'll go up there, no problem, yeah. So you can fly with it installed or not installed. It's really on how you're going to be doing your ground operations. It is required to be installed, though, if you are landing on a prepared, unpaved surface. The architecture of the aircraft is we have a utility management system. Essentially, that's software that monitors all the valves, control positions, sensors, and then that data is then sent through up to the avionics. So the avionics and your information that's been provided through your pitot tubes, et cetera, are all communicated within the aircraft. The benefit of having the utility management system is that it will automatically change loads as necessary within the aircraft. We talked about QPM, or quiet power mode. When you go into quiet power mode to protect the pilot from making a mistake and overloading the electrical system, it will automatically depower certain systems that you cannot even actuate. So it's a great kind of like the brains of the system. One of the things that it will do, and we may or may not see this on our flight depending if we get into icing conditions, is that it will help with the automatic ice detection. So you can see we have our ice detectors right here. If the ice detectors detect ice in flight, the UMS, the utility management system, will automatically command on all your icing systems. So you as a pilot are not flipping switches or anticipating in your icing. You're not interacting to flip a bunch of switches to command your ice protection on. It happens automatically with the system. The other thing that the utility management system will do is it will, when we go into the aircraft, you'll see a variety of synoptics. All those things are monitored. It will open and close bleed valves as necessary. It controls everything in the background. Again, we talked about that this is a single pilot qualified aircraft, and the design and the architecture of the brains of the system, if you will, the utility management system, support the pilot in that role. So you'll find that the workload is very, very low in the cockpit because many of the items where a pilot would either have to be doing analysis on, UMS has already done the analysis, or take action, UMS has already taken the action for you. So then you're monitoring what the UMS has done for you. So that's a really neat part of the architecture of the aircraft.
It's worth noting here that the UMS handles some really, really cool intelligent features on board the aircraft. So for example, when you land, it automatically deploys the spoilers. It knows once you're on the ground and deploys those automatically. You don't have to actuate them as the pilot. And then once you bring power back in, it will retract those. Also, if you tried to deploy the flaps, but you're above the flap speed, it won't deploy the flaps. It'll just give you a message that says flap overspeed. Or if you completely lost cabin pressurization, the aircraft can actually descend itself and make a 90-degree turn while you regain consciousness. So there are all kinds of incredibly smart features just like this on board the aircraft that make it really, really friendly for single pilot operations.
A couple other things. So the aircraft, we have an IRS, which is somewhat unique in the size of aircraft, inertial reference system. Those terms have been used in the past as an INU, Inertial Navigation Unit, INS, Inertial Navigation System. But these systems are gyros, and this one, our IRS, is a Honeywell laser ring gyro. that provides information to both pitch, attitude, roll, but also position in terms of where you're at geographically. That information then is sent through the avionics to a variety of systems. The left-hand side of the aircraft runs off the IRS. The right-hand side runs off of an AHRS and ADC to provide information to the pilot. So you can see here, what comes standard on the aircraft now is a lithium-ion battery. Lithium-ion batteries made by TrueBlue. This is a TB40. There's 2 of them on the aircraft. These are phenomenal batteries. Their power capacity and ability to recharge beat nickel, cadmium, or lead acid significantly. A lot of concerns that folks have with lithium ion is the perceived potential for fire. We hear a lot on different types of technologies out there as mopeds or toys or something that kids have. But that fire potential is based on the ion. So all lithium ions are not made the same. It's what types of other chemicals that they use to bond to the lithium. And TrueBlue in this one uses a ferrous material. So it's a lithium ion based on a ferrous compound. What that means is that it is very robust and resistant to fire. The lithium ion battery also has its own computer inside of it. It will monitor the system and then communicate to the UMS, the utility management system, of its status. You can see that there's no thermal blankets on the lithium-ion battery. When you power on the battery or you test the battery, it knows what the temperature is outside, so it will do a self-heat on its own to make sure you're ready for engine start. So there's no need for external heaters or anything. It uses its own battery power to condition itself to be ready for start and operations in flight. The lights on the aircraft are LED. And in each light array, there's multiple different lights that will be commanded on by what you select in the cockpit. You can see we also have those on the wingtip. Over here, it's kind of flashing, but you can see under one light system, all the different lights work within the array. Oh, let's go around to the other side, point out a couple things. So the first thing that we have here is single point refueling. You do have the option to do overwing fueling if you're in a location where there isn't single point available, as you can see right out here on the edge of both wings. But right here we have a single point fueling receptacle. You can see right now the total fuel on the aircraft is 2,900. If I wanted to refuel it, I can select that here, or even better, I can select it in the cockpit. You'll see that tomorrow when we get up to Spearfish. After we land, I will select a fuel load that we need to return, and then that will be set. I can walk away from the airplane, and line service can come up and single point refuel the aircraft.
So you just type it in, tell them to fill it up till it stops.
Well, yeah, exactly. So yeah, I type it in, and this will come up, and then they won't be able to overfill it because it will stop at the appropriate level.
Yeah, that's handy.
Yeah. This door is monitored, and you see some of the neatest things about Pilatus design is they think through a lot of the engineering. If you notice, as I close the door, the panel went off. You can see right here, this bar is connected to the door. So if you leave your fuel panel on and you go to close the door, you'll see that as I close the door, it shuts the fuel panel off. So this is our externally serviceable toilet section here. Obviously on the inside you saw that we have a vacuum toilet that uses fresh water, but this is externally serviceable that makes it easier on the pilot there. So you can drain the water for cold weather operations by opening this valve. This is the cleaning valve, and in here, of course, is the toilet valve. Similar to the door on the fuel panel, these levers here will prevent you from leaving something open. If you take a look at this valve right here, which I'm not going to open up, if this is extended, this door will close that so that your waste valve will automatically close by closing the door. So all of our doors have things on there that need to close valves in the system. This one's actually really cool. So this here goes in here. So if that is down, it will slide up. So both valves will close by closing the door. Little things are thought about here so you don't hit the flaps, no matter what flap position.
Oh yeah.
So on all the doors, you'll see that You can open them in any flap position. You'll see it on the cargo door also on the other side.
Yeah, it looked like the cargo door is kind of cut out that way.
Exactly,
too, a little bit,
exactly. So there's no restriction on the flap position, because it'd be a challenge, like if you forgot to put your flaps up, or you know whatever it might take. So this cutout here is to allow for different flap positions. So come down here and look at the main landing gear. You can see that the actuator, it's an electric actuator. The only thing that's hydraulic on the aircraft are the brakes. And the brakes are run off an electric hydraulic pump, so the engines do not supply hydraulic power to the aircraft. Everything else is electrically operated, or it's operated through push rods, pulleys, and cables for flight controls, or a combination of that and electrical power. You can see here we have a nice a door there, so when the gear come up, it reduces a bit of drag, and you have your hub on the outside. So when this is retracted, you'll see the sidewall of the tire as you're flying along, and I'm sure you've seen photos of that. You can see how beefy the strut and landing gear are. It's got a trailing link system, as you can see right back here. You can see the pivot arm sits behind the actual front of the landing gear. The brakes are here. The very top white right up here is a hard landing indicator. If that's knocked off during landing, then you had a hard landing. One of the things that's interesting, it doesn't look like there's a lot of strut compression available to the pilots, but when you're in flight, the gear actually hang down. That strut extension will be a good few more inches extended, so that you have that compression to where it's at right now.
The exterior of the PC-24 is stunning, and the inside is no different. It is really striking when you walk inside. Starting all the way in the back, that cargo area is huge, and that cargo door is massive, and you can fit so much in that area. And best of all, you can also access all of that while in flight. Some of the PC-24s are outfitted for medical missions, and so they're designed to get everything on board, all the way from motorcycles to stretchers and everything in between. Having a cargo door with that level of access is really, really handy. In front of the cargo section is the passenger section, which can be configured in a lot of different ways. And it's really nice that it has a flat floor throughout the cabin. Some other jets this size have a dip in that middle aisle going all the way back, but the PC-24 doesn't, and it's flat all the way through, which makes that cabin feel really spacious and luxurious. Speaking of which, the upholstery work is just beautiful. And I got to tour the factory in Broomfield, Colorado, where they finish out the interior of Pilatus aircraft for pretty much all of the Americas. So they finish most of the aircraft in Switzerland, fly it all the way across the Atlantic to Colorado, and that's where they do the paint and the interior. I got to talk to the folks that assemble all of these aircraft by hand. I vividly remember seeing how they select which parts of raw leather hide that they use inside the aircraft. They have someone inspect it to such a granular level where they can tell where there might have been like a bug bite on the hide, and they exclude that tiny portion of the leather that they're going to use. So it was cool seeing all of the leather hides laid out there with little markings on it showing exactly what parts weren't quite perfect enough to make it into the airplane. And so it was really cool to see something this technologically advanced be made by hand like this. And the end product is just an absolutely amazing interior that is so luxurious. Getting towards the front of the airplane now, the entryway might not look like a bathroom, but the whole thing converts into an enclosed bathroom really quickly. So Pilatus's perspective on this was that for the range of this aircraft, you probably aren't needing to routinely use the bathroom a lot, so why waste that entire baggage section in the back with a lavatory that doesn't get a ton of use? And so instead, they just cross-utilize the front of the aircraft to function as the lav. So it's really cool to kind of see in Transformer style how the whole front part of the airplane turns into a bathroom. It's pretty cool engineering. And that brings us up to the cockpit. Now the cockpit is visually stunning, and some of the very best features of the PC-24 are right here. And in the video on the screen right now, Gerard is going to provide a deep dive walkthrough of the cockpit and the avionics on board this awesome airplane. It is really, really interesting. I promise you don't want to miss it. So I'll see you there.